Okay, this is my semester project. This is the robot that I had already built, but the difference is instead of using this Cypress PSOC to run it, I am now using the ATmega168. The ATmega can only control one or two servo motors at a time. So I have to run it through this board here. So this is basically an I2C breakout board, which I got from Adafruit. Love that website. So you can see it's connected over here to pins 27 and 28 on the ATmega. And then the other ones are just for power. And then from this board, sorry, you can sort of see, these are all the servo motors connected. Yeah, so a little tour on the robot. There's 16 servo motors in total, 4 for the eyebrows. There are 4 that, well, there's 2 that do the pitch of the eyeballs, 2 that do the yaw of the eyeballs. This tilts the lids up and down, and this one back here opens and closes the eyebrows. And then I have motors that control the lips up and down, and then there's a motor over here that opens the mouth. Then down here, you can pitch the head using these servo motors. Generally, I just give them a command to go to this exact position, and I call the function stabilize, because I don't like to shake the head around too much. And then underneath, there's actually a last motor that actually can turn the neck. So the purpose of this project was partially to use the ATmega instead of this old PSOC, and that's really great for a bunch of reasons. One of them is that using the PSOC is a pain because you have to have all this software installed on the machine in order to use it. Whereas with the ATmega, you really kind of don't, or at least the software you need is much lighter weight. So that's good. The other thing is the C code was much easier to write for the expressions, and as you're going to see in a few minutes, I started out by doing all the phonemic movements. So basically, like, you know, right eyebrow left up, eyebrow left down, eyebrow left middle. And I started out that way because that's the only time I actually have to specify in milliseconds the pulse length for this motor. That's the last time I have to do that. So I can make all these complicated, I can make much more complicated expressions without actually talking about those pulse length. I can just say up, down, middle. And that was a big part of this, is abstracting up a lot of the programming. So I'm gonna run, actually I've already flashed the card, but I'm gonna run just a basic main loop. And it's gonna run through 4 different functions. One of them is called all home, and that tells every single motor on the machine to go to its middle position, with the exception of the mouth, because the middle position would be hanging open. But basically they all go to what I have specified as their home position. Then we're gonna do outer eyebrows up, so you're gonna see these guys come up. I just like that because it's funny. We're gonna do one called look up, which makes both of the eyeballs look up. And then we're gonna do one called smile, which makes the lips move up and sort of smile, although frankly these lips are a little bit tight, so this motor isn't really able to crank all the way up. If I was making not a prototype robot, I would use much more robust servo motors with metal gears inside. These are the cheapy $2 ones with plastic gears. All right, so let me plug this guy in, and then I will flash the card just to make sure that it's running. I'm gonna flash. All right, here we go. So it's gonna run through a loop, so that's eyebrows up, look up, smile, all home. So this is, it seems really basic, but really part of my goal was to create expressions that were built on much simpler expressions using sort of the same kind of theory as you would build complex meaning from basic sounds, because basic sounds put together make words, words put together make phrases, phrases, sentences, paragraphs, etc. So that was really the point. So, there she blows, a functioning robot using the ATmega168 and the I2C breakout board that I got from Adafruit. All right, thanks.